Hello and welcome to this Prep Up series by CGPA Booster. This session is going to be an introduction for the DBMS series that we are starting soon. Before starting, I would like to go over the syllabus. Before that, I would like to give an introduction about myself. My name is Savi Sahai and I will be taking the series for DBMS. Going over the syllabus, we will have DBMS versus RDBMS. DBMS stands for Database Management System, and RDBMS stands for Relational Database Management Systems. We will then be going over the databases, tables, the different normalizations such as type 1, type 2, type 3 normal form. Then we have B, C, and F, which you will know in a while what it means, what are the various factors that it depends upon, etc. We'll be then covering the DBMS schemas, data models, data independence, ER model, generalization and aggregation. We'll be also covering relational algebra, DBMS indexing, DBMS hashing. Then we'll go on to the one of the most important aspects of DBMS, which is the database languages like DML, DDL, and DCL. The full form and the various theories, the various parts that are related to it will be known to you all in a short while. We'll be then going over DBMS transactions, DBMS concurrency control, DBMS deadlock, database replication, distributed DBMS, data recovery and backup in DBMS, database security, and last, we'll be covering the database management systems query. So let's get started. I hope you all are quite excited because I am. So moving on to our very first thing, that is, what is a database? Now, when we hear the word database, what strikes to us is that it may be a collection of logically related data held together. That is the first thought. Going over to the formal definition of this. A database is a shared collection of logically related data designed to meet the information needs of an organization. The related information, when placed in an organized form, makes a database. The organization of data, which then converts into an information, is necessary because unorganized information has no meaning. Now, in short, if we have to really talk about what it will be, is if data that is available in our day-to-day life is just given at once, it won't make sense unless until arranged in a manner so that it can be easily understood. That is basically a database. Then we'll ask what were the things that were available in the previous times that this actually came into picture. As we all know that there is always a problem and then we come to a solution. That's how humankind works. So was the case with DBMS. How did it come up? How did it actually start? Let's go over this. Now, before going over what and how did it come into picture, let's give a little more detail on an example of the various available databases. Now, the university database, it will be an example that will store the data about students, faculty, the courses, etc. There can also be banking management systems that can be heard of because, again, there are various customers about whose the details need to be stored, like name, contact number, various account numbers, etc. So that's how we come across. What's the purpose of DBMS is to keep an accurate track of the academic activities of the university or colleges or anything that you can think of, putting in a group of collections. Okay. Right, right. As I was talking about, how did DBMS actually come about? Now, for knowing why did it come about, we need to go over what was there that existed before DBMS. Now, before DBMSs were introduced, organizations usually stored information in file processing systems, which had a number of disadvantages, such as data redundancy and inconsistency. Now, what does data redundancy actually mean? Is that there would be repeated data, and because of that, there was space that was occupied by it. And when we know that when there is space occupying, the costing of that increases. Then we come to the inconsistency part of it. What is inconsistency? As the name suggests, there were similar names that were stored in many places. And sometimes, if a change is made in one place, that used to not reflect in the other. This caused a lot of chaos. And that's how we thought we should come up with a better solution. And that's when we came up with DBMS. Let's go over some more problems that we faced in file processing. Difficulty in accessing data. As mentioned before, the same name might be mentioned in 4 places. Getting one but not the other would actually create a lot of mess. Then there was an data isolation problem that was faced again. Integrity problems, atomicity problems, concurrent access anomalies, and security problems. So all these will be covered in the later slides or in the later videos, so that you all get a in detail idea about what can be done. Right. Now, again, it's important to know the basic difference, as the previous slide just mentioned in brief. Right. So we'll go over that. Now, file system. File system is a software that manages and organizes the files in a storage medium within a computer. What is DBMS on the other hand? DBMS is a software for managing the database. In file system, redundant data can be present in a file system. In DBMS, there is more. In DBMS, there is no redundant data. In file system, there is less data consistency in the file system. Whereas in DBMS, there is more data consistency because the process of normalization. Now, to elaborate on this point, you all need to be with us for the upcoming videos. Then we'll go over the last point that is there, which is one of the most important points to look from a business point of view. That is that file system was less expensive, however, but DBMS is more costlier. Then why do we really consider it? It is because it has more security mechanisms, and so it increases the cost. Database management system. Now, we went over what a database is, but let's go in detail about the management system as well. Now, DBMS is a database management system in which the software system that allows users to define, create, and maintain a database and provide controlled access to the data. One of the major points and advantages of database management system. A database management system, DBMS, is basically a collection of programs that enables users to store, modify, and extract information from a database as per the requirements. That was another important point, as mentioned previously, that finding out one person's name in one column and not in the other caused a lot of chaos. And at the end, we all are working to make our lives easier. Moving forward, we come to the operations on the databases. Now, what were the different operations that can be performed is to add new information, to view or retrieve the stored information, to modify or edit the existing information, to remove or delete the unwanted information, arranging the information in a desired order, etc. Now, the advantage or one more advantage that can be seen is that since it is in an organized manner, it's easier to add or delete or retrieve any information that is available, which was a major disadvantage in the file processing system. Okay, few examples and applications of DBMS as mentioned before as well. We have banking as one of the examples. We have airlines, the various reservations, the schedules of the different airplanes that are going to and fro. There are universities that use DBMS, again, very important. There are sales such as in customers, products, purchases, etc. One of the important points in today's world where everything is turned online and is preferred, we have online retailers using DBMS to their absolute advantage. Then we have manufacturing. Many of the factories, it helps in like the supply chain, production, inventory, etc. Last but not least, we have human resources. For example, keeping a track of the employees, the records, the salaries, tax deductions, etc. Now, when we talk about a database, we need to know the various components that make the database. So, the five major components of the database are hardware, software, data, users, and procedures. Now, this is an overview of what it actually consists of. Let's have a look at this diagram. Now, what do we see in this diagram is a pure representation of how DBMS actually works. At one end, we have the application programmers, for instance, us, and the end users are the customers to whom we actually provide this entire system. The middleman is actually what connects the application programmers to the customers, and that is DBMS. So at the top part is what we see called as database, and what it consists of are data and programs, various data that is converted into information, and the relevant operations that can be performed to help connect the two. So that is a basic outline of how database actually looks like. Going in detail for every term as mentioned in the previous slide, components of the database system continued. So we have hardware. Now it is the actual computer system that is used for keeping and accessing the database. DBMS hardware consists of secondary storage devices like hard disks, etc. Then we come to the second most important component of DBMS, that is the software. That is the actual DBMS between the physical database itself and the users of the system in the layer of the software called as DBMS. As mentioned over here, what actually connects the application programmers and the data and the end user is the software. Then comes the data. Now, software, for instance, if we just write a code, it won't make sense unless until we actually test it. Now, for testing, we need some data. And that's when this component acts as the bridge between the machine components and the user components. Then comes our users, for which we actually design the entire database system. There are a number of users who can access or retrieve data on demand using the applications and the interfaces provided by DBMS. The users can be naive users, online users, application programmers, sophisticated users, and database administrator. Last but not the least, we have procedures. Now, it refers to the instructions and rules that govern the design and use of the database. The users of the system and the staff that manage the database requires documented procedures on how to use and run the system. Now, this acts, it might seem that it's not a very important component, but for instance, if one person is already gone and they don't know how to work about it, this point comes into picture because that helps them understand how to actually go about things. So that was about the components of the database system. We will be going over all these terms in detail in our upcoming videos, but to just give a brief introduction about the same, we'll be going over data models, schemas, and instances. So what is a data model? A set of concepts to describe the structure of a database and certain constraints that the database should obey. What is a schema? The overall description of the database is called the database schema. A schema is defined as an outline or a plan that describes the records and the relationships existing at the particular level. Instance is data in the database at a particular moment in time. Now, these terms may seem confusing right now, they might be overlapping, etc. But don't worry, we will be covering all these in our upcoming videos. So stay tuned with us and hope to see you all soon in our upcoming videos. Before going, do show us some support, hit on the like button and do subscribe so that you know when the next video is coming up. With this, I'll take your leave. Thank you so much.